So welcome to the live class for today. Thanks both of you for being here. We're going to talk about a geometry topic first, classifying quadrilaterals. Then we're going to take some questions from you guys if you're having specific questions from your course. Then we'll talk about multiplying complex numbers. That's an Algebra 2 topic. And then we'll take some more questions. My name is April Barton. I'm one of the math teachers with Graduation Alliance. I may be your teacher, or you may have Janae Russell or Karen Whitehead. There's a couple of us now, but you're always welcome to contact me or to send your teacher chat messages when you have questions. So let's get started with the classifying quadrilaterals. So a quadrilateral, that's a fancy name for any shape with four sides. Some of the shapes you probably already know. Squares, rectangles, parallelograms, all of these are considered quadrilaterals. Anything with four sides is considered a quadrilateral. If they have special properties, then they get an even more special name. And those are some of the shapes you already do know. So one special quadrilateral is a parallelogram. And a parallelogram has two sets of parallel sides. This is what makes it a parallelogram. So when they show it, you can look at the shape and see, well, this kind of looks like a parallelogram, but it also needs to be marked. They need to tell you that the lines are actually parallel. So the little arrows on a shape indicate that these are parallel lines. They don't necessarily mean they're the same length, even though these lines are. They just say they're parallel. So a parallelogram is technically still a quadrilateral. It basically has two names. You can give it the name of parallelogram, or you could also call it a quadrilateral because it has four sides. So each shape usually has multiple names. For example, a rectangle. Let's do a rectangle next. A rectangle, which you've seen before, it's actually a parallelogram. It has two sets of parallel sides, so it's considered to be a parallelogram. But what makes it even more specific and more special is that it also has 90-degree angles inside. Instead of being kind of tilted, it looks more straight up and down. So a rectangle has three names. A rectangle could be called a parallelogram. It could be called a quadrilateral, but its most specific name is rectangle. We also have a rhombus. A rhombus is also considered to be a parallelogram. It's still tilted. It still has two sets of parallel sides. But what makes a rhombus, again, even more special is that all four sides are the same length. So we need to mark these sides with just this little line. I call it a tick mark. And that indicates these are all the same length. My picture's a little off because it's hard to draw these by hand, but all four sides, if they put the markings, they're assumed to be the same length. So this is a rhombus. And then the last thing from this group is a square. And a square, again, is more special. It's still a parallelogram, still a quadrilateral, but you can also call it a rectangle. You could also call a square a rhombus. A square is the quadrilateral with the most names because it fits a lot of the requirements. It has parallel sides, it has 90-degree angles, it has all four sides the same. So you could call a square a rhombus, a rectangle, a parallelogram, or a quadrilateral. We also have a kite. And a kite looks like the classic version of a kite, probably like maybe you've seen in Mary Poppins. That movie's pretty old, so not everyone's seen it, but classic version of a kite. It has no parallel sides, but the top two lines are the same and these bottom two lines are the same length. And then we have a trapezoid, which only has one set of parallel lines. The top and bottom are parallel to each other. Or we have an isosceles trapezoid, which again has parallel top and bottom lines, but this time the sides are equal. So then the assignment, the geometry assignment that you work with on these quadrilaterals will ask you to name a shape and give it its most specific name. So even though some of these could have more than one name, we want the one that's most specific. So on this page, what is the most precise name for the shape below? And this question I want you guys to answer. This one had a lot of definition and buildup. What's the most precise name for this shape? And you can type your answer into the chat box. Thank you, Jermaine. Jermaine said square, and you're pretty close. It does have all four sides the same. It's slightly tilted. A square, even though, again, this could just be my drawing skills too, it almost looks like these could be 90 degrees. If it's not marked, you can't assume they're 90. So don't just trust the picture and just what it looks like. Look for the actual markings as well. So instead of square, what's the only other shape that had all four sides the same? Good, a rhombus. So again, don't just look at the picture and trust it by what you see. I could see this looking kind of like a square. It's not my best drawn rhombus, but since they don't mark these 90 degrees, you can't assume it's a square without those markings. So we're a little early. Usually we spend 15 minutes on a topic, but that's all there is to that topic. So now let's take questions. Do you have any specific questions for your courses for things you're currently working on and want some help with? And again, you can type into the chat, or if you want to enable your microphone, you could turn on your microphone and ask that way.
Oh my gosh, yeah. School districts right now is not a good idea.
I'm not hearing anything, but I saw someone unmute themselves. Okay, so we did get a chat message working on polynomials. I may be having technical issues because I still haven't heard anything. If you enabled your microphone and do have a question, try chatting it to me instead. I'm not sure if my sound is off or something. Okay, so we have two requests, polynomials and geometric squares. So let's start. The first one I got was polynomials. Sorry that I cannot hear you today. I'm not quite sure what's wrong with my sound. Oh, you can't see anything. That would be a problem. My screen should have been shared. It does say it's currently being shared. Hide video panel. Double check your menu and see. Double check your menu and see if you have to enable anything to see my screen. We just had a new student join. Thanks for joining us, Mariah. We're trying to fix a quick technical issue, and then we're going to talk about polynomials, and there was a correction, geometric sequences. Probably said squares because we had talked about squares as part of the quadrilaterals. Also, maybe you might have to switch back and forth between your video itself and seeing my screen, there might be like a toggle button to toggle the actual screen so you can see what I'm writing. So since Jackie was the one who asked about polynomials, I'm going to give her a second to kind of mess with her settings, and I'm going to go ahead and talk about geometric sequences. Since Jermaine can see my screen. So one of the problems is my setup is a little bit different since I'm the one actually running the session. So I'm not sure if there's like a specific button to push to see my screen. All I know is I can share my screen. But just look through your menu options or look for any buttons to toggle. And Mariah, if you want to ask any questions, you can open up your chat box. For some reason, my sound isn't working today. So you'd have to open up the chat to see any of the messages from that or to send me a message. So geometric sequences, I'm trying to think of the correct notation we used. It should be AN equals A sub 1 times R to the N minus 1. So that's the actual equation. Sometimes you're asked to find the equation, and sometimes you're just asked to like find the next term. So sometimes they'll just give you a list of numbers. I gotta grab my calculator to make this problem up. They're gonna get big fast. So next one would be 243. And then negative 2,187. So the question could just ask you to find the next term. So if you're going to find the next term, you need to be able to figure out, well, what am I multiplying by every time? If it's specifically a geometric sequence, then you're specifically multiplying every single time. So what number do we multiply 3 by to get up to a negative 27? And for some reason, my sound must not be working today, so you're gonna have to type it in. Thank you. And if you don't want your video to be shown, I can disable that for you. It's totally up to you. It is recorded, so I think your face will actually be part of the recording. I don't know how to disable that. So we had one answer of 7, which is pretty close. 3 times 7 is 21, though. This is why in elementary we learned our multiplication. It's really hard to get all those memorized. So if you ever are in doubt, use a calculator. 3 times 7 is 21. We could also figure it out and say, well, add 3 again, you get 24. So 3 times 8 is 24. Add 3 one more time, and now we get 9. The only thing we need to change is that it should be negative 9 now. Positive 3 times negative 9 takes you to negative 27. So once you know that common ratio, then you can multiply the last term by that common ratio, and that gets you the next term. So if the question is find the next term, we would take negative 2,187 and times it by 9. And that's super big. Let me just pull up a calculator so you can see. I like to use Google Calculator or like Desmos Online Calculator. So 2,187 times 9
How can I go to this thing?
is 19,683. Pretty big number. And it was a negative times a negative, so it's positive 19,683. A question might also just ask you for a common ratio. So the common ratio is actually a number we already found. You have to find that common ratio to do the problem.
I'm looking at this to see if how can I do this? I don't even know what Zoom is.
So negative 9, if it said what's the common ratio, that's negative 9. The last thing is maybe they want the exact equation. What is the equation you could use to represent this geometric sequence. So each of these terms has a meaning. A sub 1 is the first term. It's the first number on whatever list they give you. So from our list, what's our first term?
3.
Mm-hmm.
3. A.
So A is the first thing of our equation. That is a first. We want the first term from the actual list of numbers. This whole thing is the generic equation. We want from the list of our numbers, what's the actual first number written on that list? The 3. Good. So the first term has to do with the actual numbers. Then the common ratio, the R, we've already found. We know R is -9. And then the N, we don't always fill in, depending on how, again, the question's asked. So the first term was our 3. So our equation now is going to be 3 times the common ratio of -9. And if it's negative, we usually put it in parentheses, to the n minus 1. So first number went first. Whatever number we multiplied by went in the spot with the R. And the n is whatever term you're looking for. If the question asks for what's the equation, then we're done. If the question says find the 20th term, actually that's way too big for geometric. Find the 7th term. Now we can use the equation to find that. Instead of just continuing on the list, we plug in 7. 3 times -9 to the 7 minus 1 would give us the 7th term. When you go to plug this into a calculator, it's good to just do this -1 part first. You don't want to mess with the calculator with that part. So 7 minus 1 is 6. And then we just plug this in. So don't do this part by hand. It's really hard to do in your head. You really want to use a calculator. So 3 times parenthesis. On Google Calc, you just use the minus sign for negative, so -9. And then on Google Calc, it's this XY. That makes an exponent box for you, and you can type in that 6.
No, calculate on Google.
So pretty big number. Let's see, 1,594,323. And now it's not letting me write it. I'm going to have to refresh my page really quick. I'm not sure why it's giving me, I'm having a lot of technical issues today. Sorry, guys. But while it's refreshing, we know that answer. So Jermaine, did I answer all your questions about geometric sequences? Is there anything you'd want to talk about a little bit more? Oops. Okay, good. So we've answered our geometric sequences. And then Jackie had a question about polynomials. Were you able to get it so you can see my screen? You've answered a few things, so I think you're ready for the polynomials discussion now.
Is now an okay time to talk? Okay, perfect. I just wanted to check with you and make sure that I know you were having some issues.
I'm going to start on polynomials. Hopefully you fixed your screen issue so you can see my screen. Polynomials. Okay. So polynomials, that's also kind of a big topic. One of the first things that you're asked to do with polynomials is to name them. A polynomial is any combination of numbers and letters. 3x squared is a polynomial. 5x minus 7 is a polynomial. 10x to the fourth plus 5x cubed minus 4x squared plus 1, that's a polynomial. Any combination of variables and numbers. So they all have different parts to them and they all have different names. The numbers in front of a letter, these are specifically called coefficients. You'll hear that term a lot.
Okay, perfect. I just wanted to.
Coefficients are always in front of a letter though, so -7 is not a coefficient. -7 is a constant because it's not attached to a variable. So a variable is the letter itself. X is the variable. And technically you can use any letter. Most of the time you'll use X. And then each thing altogether is considered to be a term. 10x to the fourth, that entire thing is a term. Or 5x cubed is a term. So once you know the parts, then you can give it a name. And I just saw that Jackie is raising her hand. Did you have a question? Or can you still not see the screen? Again, I'm not sure why. I think my sound might be messed up. I can't hear you guys from the microphone, so you'll have to type a chat message if you have a question. Still not seeing a question. Again, if you want to type in a question, just do that whenever you're ready, and I'm happy to answer it anytime. I'll keep going on polynomials until I do get some questions, though. So polynomials always have two names, and I'm actually doing backwards. We'll start with the first part of the name first. The first part of the name is based off its degree. So you can have names like constant, linear, and quadratic. And I think we go up to cubic. We'll include cubic just in case. So each of these names has a specific meaning. Constant is if you only have a number and nothing else. No variables at all. Linear is when you have a variable and it's only to the first power. So you can have a variable and a constant. It just has to for sure have this piece. And when there's no exponent written in, it's assumed it's an exponent of 1. So that exponent of 1 is what makes it linear. Sorry, polynomials have a lot of definitions again, so we'll be going through a lot of definitions. Quadratic is when you have an exponent of 2 as the highest exponent. Yes, there is the exponent of 1 here, but 2 is the biggest, so we call it a quadratic. And then cubic is when you have an exponent of 3 as the biggest exponent. And it doesn't matter, it doesn't have to have squared and a constant. For sure, you just have to have that x cubed to make it a cubic. So then you also name it by the number of terms. So we have monomial, binomial, and trinomial. And I think that's as high up as we go. So monomial is one term. Binomial is two terms. Kind of like a bicycle has two wheels. And trinomial is three terms, kind of like a tricycle has three wheels. So when you name a polynomial, you've got to pick one name from each. If we had 3x squared plus 7, let's name this polynomial. So you have to look at the degree to determine the name from the first list, and then you have to count how many terms are there for the name from the second list. So in the chat box, let's answer what's the name of this polynomial. Cubic. So I had two messages that I was reading really quick. Cubic is if it's a 3 that's the exponent. So even though there is a 3 there, the 3 is not in the right spot. The 3 is the coefficient, and that doesn't tell us the name. It's the little one up above. But that's a common thing that happens, so it's good to talk about and see. It's this one behind. We actually don't care about the number in front of x squared. So the other example, or the other answer is quadratic, which is correct. The little 2 means quadratic. But I can see where you got cubic from because there is a 3 here. So quadratic's the first part of the name, and then by the number of terms, how many terms are there? So it's a quadratic for the first part, but each term is split up by these plus signs. So we have 1, 2 terms. So if there are 2 terms, what name do we use for 2 terms? So that seems like the our answer is uno or dos pies. I don't speak Spanish, I apologize. So the term, there is 2 terms, but we use the word binomial. I don't know if there's a correct translation to Spanish because I don't know the language. So the full name is quadratic binomial. Oops, sorry, I didn't mean to click on that. Golly, okay. So then, is there more about polynomials you would like some help with, Jackie? That's a basic overview of how to name them. You might also have to add or subtract them or multiply them. You said when you're squaring something, I think what you mean would be if you square something like this. I just want to make sure we're on the right type of problem for you, Jackie, since you're the one who requested this topic. And we had one more person join. Thanks for joining us today. Unfortunately, my sound is not working. I cannot hear you. I don't know what's up with that. So you'll want to open up your chat box if you have a question or anything or want to answer a question that I ask. You'll want your chat box up. I'm not sure how to fix my sound today. And I'm still not seeing a response from Jackie, so we'll have another chance for question time. And if you have a specific, if I missed something with polynomials, please let me know, Jackie, and we can address that in the second question time. So the schedule for right now is multiplying complex numbers. And multiplying complex numbers is actually similar to multiplying polynomials. They're very much the same. The difference is I is kind of a weird term to work with. It's not the same exactly as a regular variable. So an imaginary number comes up from trying to square root a negative number. When you square root, the purpose of square root is to say what number multiplied by itself is 25. 5 times 5 makes 25. Therefore, the square root of 25 is 5. With negatives, we don't have a number that can multiply by itself. A negative 5 times a negative 5 makes positive 25. So we want negative 25, not positive. And positive times positive is still positive. And a negative times a positive, these are not the same, so they can't work. It must be exactly the same. So what they came up with is that when you square root a negative number, that's 5 with a variable I next to it. They call this an imaginary number. 5i times 5i equals that negative 25. So I comes from square rooting negatives, and its most basic form, if we square root a negative 1, I'm going to do a little erasing so there's not so much going on. Square root of negative 1 is I. And this is important because I squared is going to equal negative 1 itself. Square root of negative 1 squared is just negative 1. We do have a question, cosine, sine, and tangent. Right now we'll finish talking about complex numbers, and then that will be our first question unless I hear back from Jackie about polynomials. We'll talk about cosine, tangent, and sine during our question time. Thank you for your question though, Mariah. We will get to it. Let's finish our talk on multiplying complex numbers. So when you multiply complex numbers, it can be different. You'll see these problems are mostly the same. 3 has no I on it for the first problem, and 3 does have an I on it for the second problem. So for the first problem, it's pretty much exactly like multiplying polynomials. You just distribute it in. 3 times 5 is 15. Then you have to use the 3 again. 3 times negative 2i is negative 6i. Then when we change it to 3i, that makes it a little bit different. The 3i times 5 will be the same, 15i, but we just do the multiplication. The 3i times negative 2i will have a little bit of a difference. 3 times negative 2 is negative 6, and I times I is I squared. I squared has an actual value. Okay, we also got another chat message. I did answer Jackie's question about polynomials. That's great. So after we finish this page on complex numbers, we'll get to sine, cosine, and tangent. So I squared has an actual value, whereas x squared, unless we're working with an equation, we don't know any value for it. You know, I squared is negative 1, so we can now replace that. Negative 6 times negative 1, and you actually combine that together. So 15i plus 6 now. A negative 6 times a negative 1 is a positive 6. With these numbers, this is called a complex number because it has an I and a number that doesn't have an I, the real part. They always want the I part second, so we do have to switch the order to be 6 plus 15i. So that's how we multiply our complex numbers together. Okay. So then we had a question about cosine, tangent, and sine. So with cosine, tangent, and sine, you must use a calculator. Those are definitely necessary. You can use Google Calc. The problem with Google Calc is it always starts you in radians and you have to be in degrees. We never use that RAD, we always use DEG. So this is one of the times where I think Desmos Scientific Calculator is a little bit better. And again, you just Google for it and click on it and it'll bring it up. So that one automatically starts you in degrees. So we'll come back to this when we need it for a problem. So sine, cosine, and tangent are based off of triangles. When we have a triangle, we have 3 sides to the triangle. This side here is called the hypotenuse of the triangle because it's across from the right angle. So the right angle can be in any corner of the triangle. There will be a right angle somewhere, and the hypotenuse is always across from it. I always think of it as not touching it. If I drew this line in, it would touch the right angle. Or if I drew the bottom line in, it would touch the right angle. So the hypotenuse is always across from it. The other 2 sides, one will be called opposite, one will be called adjacent. On those 2 sides, it's based off your angles inside the triangle. So if we wanted to focus on angle A, angles are the space between, but we need to know what angle we're focusing on because opposite will be across from that angle. So since B to C, this side is across, it's called the opposite. And then if it's touching the angle they talk about, if they say find the sine of A, then the side touching that angle A is the adjacent. So we need all that information because these trig functions involve 3 formulas, but the formulas involve these angles and these sides, so we need to understand them first before we could even bring up the formulas. So sine of an angle is always the formula opposite over hypotenuse. Cosine of an angle is always given by the formula adjacent over hypotenuse. And tangent of an angle is opposite over adjacent. And these formulas are always the same. You may want them written somewhere so you can focus back on them or have them nearby when you're working on a problem. So if we give actual numbers for the sides, we can find any of these trig formulas. If we said the adjacent side is, let's make it a little believable, let's make opposite 3, adjacent 4, hypotenuse 5, then sine A, we could actually fill in with numbers. What number would we put in for the opposite? Good, 3. And then what would we put in for the hypotenuse? 5, good. So sine of the angle A is 3 over 5. If this is all they want, if they said find sine A, this can be your final answer. If they said find cosine A, we would just use the other numbers. Cosine would be 4 over 5 because it's adjacent over hypotenuse. So that's one version of a trigonometry question they can ask. The group name for all sine, cosine, and tan is trigonometry. So you might hear me say that just to refer to all of this topic together. So they can also give you problems where you might have to, let me change how the triangle looks because you can rotate it around and still have a problem to work on. So instead of saying find sine A or cosine A, they might give you an actual angle and then put a variable as one of the sides and a number as one of the other sides. So on a problem like this, they would say solve for x. We want to know the actual length of this side. So we still have to always go back to finding hypotenuse, opposite, and adjacent. That information is so important to do any of these problems. And it's always best to identify hypotenuse first. So as the hypotenuse, it's always across from the 90-degree angle. Is it going to be the blank side, the x side, or the 21? Which one is the hypotenuse? Which one's not touching the right angle at all? Good. We had an answer of 21. That's correct. This is the hypotenuse. You can also think of the right angle as like an arrow pointing. Sorry about the background noise. That means someone just graduated. We ring a little bell whenever someone graduates. So hypotenuse is across. The angle this time, they didn't say angle A or angle B. They gave you an actual angle measure. So this 32 degrees inside, we want to decide on opposite and adjacent based on that. So opposite is across from this angle. Is that going to be the blank or the x side? Which one's across from the 32 degrees to be the opposite? The blank or the x?
Hold on, what? Wouldn't you do that at angle? 90 degrees? I don't know.
Okay. So the 90-degree angle does look like it's across from the 32. The only problem is we want the side. The 90-degree angle is considered to be inside of the triangle. So we have a couple more answers. Someone said blank, someone said x. This one will be the blank side. If we highlight the actual side, this side here isn't touching the 32 at all. This blank side is the opposite. It has to be outside the triangle to be hypotenuse, opposite, or adjacent. I saw I needed one more letter on my hypotenuse. So then this side, if we draw it in, this x side is actually touching the 32 degrees. This purple mark for the 32 touches the green mark I drew for the x. So this side is your adjacent. I usually identify all three just because it's easier, but anything that's blank, we don't actually need. The opposite doesn't matter because they didn't give us any information about it. So we have adjacent and hypotenuse, and we need to know which trig formula can we use for adjacent or hypotenuse. Since you probably don't have them memorized, I'm going to go back to the page where I have them written down. So sine, cosine, or tangent, which one of those uses adjacent and hypotenuse?
Oh shit.
Okay, we had an answer of sine, we had an answer of tangent. So it has to use both. We knew on the picture that we're working on that it had an adjacent side and a hypotenuse side. So sine only has part of that information. Sine has a hypotenuse, but the opposite wasn't marked. Opposite was blank on our picture. So that puts sine out of the running because it only had part of the information. Tangent has adjacent, which is, again, is only part of the information. We don't want anything that says opposite in it because opposite was blank on our particular picture. You have to go through this process for every single problem, so you do have to watch out for that. That's why we're talking about it, though, is you're going to make those mistakes when you're looking at it on your own. So we have to figure out, well, what were you thinking and how can we fix it? So now that we know which one has both, we know we're going to use cosine. So back to our actual problem, now that we know which formula to use, cosine of the angle is adjacent over hypotenuse. We have to fill in the angle, the adjacent, and the hypotenuse with actual values. They give us these values on the picture. So A is for the angle, and that's the number inside with the degrees symbol. Adjacent and hypotenuse, we've identified adjacent is the letter X, and hypotenuse is the number 21. So we filled all those in with actual values, and then we still have one more step. This one requires a lot of thought processes and then some extra steps at the end, because our goal is to solve for X. We want to get X alone, so we need to do an opposite operation. Right now we're dividing by 21, so we need to do the opposite of division. So what's the opposite of dividing something? Good, multiplication. We can multiply by 21. When we multiply by the 21 on the other side, it cancels out this original 21. That's the purpose of doing the opposite, is to get rid of that. So this is the part where you must use a calculator. No one knows what cosine 32 is without a calculator. They used to have entire pages and pages of tables where people had figured it out by hand, but without a table, it takes forever to figure something like that out. So now we can use our calculator. 21 times cosine 32. Okay. And it will show the answer on this side. Yep, so multiply because it was division. And then again, you must just type it into a calculator. There's no way to solve this by hand. Make sure your calculator has the words DEG though. If it doesn't have DEG, it's going to give you the wrong answer. So our final answer is 17.8. If you're rounding to the 10th, I can't remember what decimal place it rounds to. I think it's the 10th. If it's like the 1000th, that would be 17.809. Depends on where they want you to round. So I think it was to the 10th. So our final answer should be 17.8. So again, be careful with your calculator. Make sure it says DEG somewhere on the screen. Usually there's a button that you just click on to switch it to that if it's not already there. So any more questions on the sine, cosine, and tangent? We could do another problem, or if someone else has a specific question from their course they'd want to talk about instead. But again, I don't know why my sound's not working. You're gonna just have to type it in. I don't know why it's being weird for me today. Okay, so it looks like we're good with the trig questions. Any other questions that you guys have from your particular courses? We have about 8 minutes scheduled. Or just general questions. When is stuff due? What if I have a computer issue? I can answer any question. Okay, so we have a question on inscribed angles. And a question on writing as a perfect square. Is that supposed to be perfect square binomial? That one I might need an example problem. So, okay, so a couple questions. Let's see what we can finish up in this little amount of time. Jackie, if you have an example question of writing as a perfect square, that would help me to understand exactly what you're asking about. I'll start with inscribed angles and look for that message. So we're going to try inscribed angles, writing as a perfect square, and geometric sequences one more time. So inscribed angles are when you have an angle inside a circle, and it touches the outside of the circle. There's central angles where it goes to the center of the circle. That's not what we're talking about right now. We're talking about inscribed angles. So there's angles inside and then a corresponding arc on the outside. And they're related to each other through multiplication and division. If we know the angle inside is 15, the angle outside is twice as much. You can tell it's bigger, it looks bigger just looking at it, and it's just multiply by 2 to find this angle outside. If instead they give you an inscribed angle and they give you the outside information, and say to find the angle inside, this is division. We take the outside arc, 120, and divide it by 2. And that's basically all there is to inscribed angles. Multiply by 2 if you're given something inside to go to the outside, or divide by 2 if you're given an outside angle and you're trying to find the inside. So let me know if I missed anything, but while you're thinking about that, I'm going to try and answer Jackie's question. Okay, looks like we're good on that one, on inscribed angles. So writing as a perfect square, if it's related to polynomials, I think what you mean is when you factor. Again, I'm not 100% sure. Okay, good. I'm glad I guessed correctly. So if we need to factor this and write it as a perfect square binomial, when we factor, we look for two numbers that multiply to be this 16 and add to be this middle number 8. So they can be any two numbers, they just have to fit those requirements. Two numbers that multiply to be positive 16 and two numbers that add to be negative 8. So what numbers would fit those requirements? What are two numbers that multiply to be 16 and also add to be negative 8?
What is that, bro?
Or we can start with just the multiplication. What's any two numbers that multiply to be 16? Okay, 4 and 4. So we got an answer of 4 and 4. So this answer is almost correct. The only small issue is that 4 plus 4 would equal a positive 8, and we want it to equal a negative 8. Well, that's an easy fix. If you change these to both negatives, a negative 4 times a negative 4 is positive 16, and a negative 4 plus negative 4 is that negative 8. So this can now be written as x minus 4, that was the number we found, and x minus 4, that's the second number we found. So those two are exactly the same, and when they're exactly the same, you can write it as 1 parenthesis squared. So this method only works if there's no number in front of x squared. A second possibility is you might have a number in front of the x squared, and then it's a different process. So if there's a number at the start and at the end, and it says you're going to factor and write as a perfect square binomial, these first and last numbers are usually perfect squares. So instead of having to go through the logic process and figure all that out, we just square root each of these. Square root of 25 is 5. If you're not sure, go to a calculator. It's usually a check mark button. So square root of 25 gives us 5. or you could use your Desmos calculator, still a check mark button. Square root of 25 still gives you 5. So these square roots, just plug it into a calculator. You may use a calculator on your final. And the square root of 36 is 6. And for some reason, it's making it so I can't write again on this document. I'm gonna have to refresh the page. I think we'll go a little over because I want to answer Jermaine's question about geometric sequences. But I just got to get this to come back up so I can write again. And nothing we had written is still there. So 25x squared plus 60x plus 36. We square rooted 25 to get 5. Square rooted 36 to get 6. And then when you write it in your 2 parentheses, the 5 came from the x squared. It was the first thing. It's going to be the first part of each parentheses. So 5, and since it did have an x attached to it, 5x, 5x. The 36 is last, and it's going to be the last part of each parenthesis. So we have plus 6, plus 6. Oh, that's a good suggestion, Jermaine. For now, it's too late. We're almost done, but maybe next time I'll use Paint or something so it doesn't give me this internet issue. So 5x plus 6 squared, since there are 2 of them, you just write the 2 parentheses as 1 and just put a squared, because that means multiply something by itself. So we're going to run a little over. Again, you don't have to stay the whole time. If you've gotten all your questions answered and are ready to go, you can log out. We had one more question about our sequences. So we're going to talk about geometric sequences again really quick. Thanks for joining, Jackie, and hopefully I'll see you next week. So Jermaine had sequences. Geometric sequences, they start you out by, I'm going to do it a little bit differently this time, by giving you a list of numbers. And we can ask a lot of questions about this list of numbers. And if you have a specific question, Jermaine, I'm going to just kind of review it all, but if you had a specific one, let me know and I can focus on that. So one question that can be asked is, what is the common ratio? So common ratio is what number are we multiplying by every time? What do I multiply a 10 by to get to a 5? I want to multiply 5 by to get to 2.5. So on our previous geometric sequences question, it was kind of easy to tell. We knew 3 times 9 made 27. This one, it's harder to tell. So if you're not sure what the common ratio is just by looking at it, you can find the common ratio by doing the second term divided by the first term. Close. 2 would be if you did 10 divided by 5. We want to do 5 divided by 10, which is 1/2. There's still the 2 involved, but really we get this decimal 0.5. So you do have to be super careful, but you can also double check yourself. If you think, I think it's 2, you can say, well, 10 times 2, that gives me 20. That went in the wrong direction. So you have to be careful, and I did this one on purpose just to show a slightly different type of common ratio that can happen. So there's our common ratio. It could also ask, find the next term. So if it asks you to find the next term, we take whatever is the last term they gave us and multiply it by the common ratio we found. This one is a little more complicated, so I don't know what that is in my head. Some of these you're like, oh, I can multiply this out, it's great. Some of these we go to our calculator. I have no idea what 1.25 times, oh, I'm gonna have to erase everything to get 1.25 times 0.5 is 0.0625. Good. Yep. So you are correct, Jermaine. 0.625. I said an extra 0 there. Okay. So common ratio, next term, they can also ask you to find the equation or write the equation. I might not have the exact wording. I don't have all the lessons memorized, but it should say something similar to that. So this is based off the general equation we saw. Every time you're starting with a of n equals a sub 1 times the common ratio to the n minus 1. And we need to fill in the a sub 1 spot with a number and the r spot with a number. This equation will be a of n equals, and then we have to put in a number here. So a sub 1 is the first term on our list of numbers. We go all the way back up here to the top, and we say, what's the first number on this list? So what's our first term? Close. 10. Yep. 1 and the 0 are actually together. It looks better when you have it typed out. When I'm handwriting it, sometimes it's confusing, but the commas are the separators between numbers. So 10 is our first term. And then our common ratio, we identified as 0.5. And then we leave the n minus 1 the same. If it asks for the equation, this is our equation. So the last thing it could ask is maybe a higher term. If it said find the 10th term, that's harder to just multiply out over and over again. So we want this equation. Even if the instruction doesn't say find the equation, we want to find the equation ourselves, because now we're going to take the equation and we're going to replace the n with whatever term they asked us to find. I'm going to actually change this really quick. Since we already have a 10 involved in the problem, I don't want you to think it's 10 every time. I'm going to say 9th term. Just so we know now, when we replace the n, we're replacing it with the number 9 because it said 9th term. It had nothing to do with that 10 in front. So before you plug this into a calculator, you want to do this subtraction step first. It's a little more difficult to plug in if you don't do that subtraction. But once you do that, now we're just typing this into a calculator. 10 times 0.5 to the 8th. (10) multiplied by 0.5 raised to, in this case it's this AB button, 8. And you can use any calculator you're comfortable with. Some have this AB, some have the Google Calc has XY, some even have a little piece that looks like a triangle, 0.5, and then this triangle piece, 8. That's telling you to do the same thing. So once you plug it in, we have 0.039. It will tell you where to round if you need to. I'm going to go ahead and just put 3 of the decimal places because I didn't specify a spot to round. So I think we're officially out of time. we have another teacher who needs to log in soon, so we've got to end for now. If you have any more questions, you missed something, feel free to email me or send me a chat message. I will go back to my email address. I can answer your questions even if you're not here for a live session. It just takes a little longer because you have to wait for me to get the email and then to respond back. But you can email me. If you're in my classes, you can send me chat messages or send chats or emails to your own teachers. We'll have another session next week. And I think there's another math one on like Tuesday or Wednesday. You should get a notification about it as well, though, because they give you the notifications of all the sessions. So thanks for coming today, and hopefully I'll see you guys next week.